Hey guys, welcome back. And today we're going to start talking about spherical coordinates. So we're going to look at a conversion factor from Cartesian to spherical. And first thing we want to do really quickly is just make sure that we understand what these actually are. So the first thing here is rho. And so rho is going to be the distance from the origin out to some point. So the rho is actually going to be this particular line right here. So this would be the distance of rho. The theta is the same as for cylindrical. So it's still going to be with the positive x-axis, and so we're going to just go ahead and move the angle out for this way. And then phi is actually going to be the angle that's created with rho from the z-axis. And so these are the three components that we're going to be using for us to find a spherical coordinate. So basically we have our distance, it's shifted out from the x-axis, which is our angle, and then again, how far away from our z-angle. And so this is what the idea is going to be for this. So if you guys look at the next page, these are all the equations that we're going to be using. I have a slide deck that actually shows you guys where these are derived from. So this is what we're going to know for this. So rho is actually going to be squared is equal to x squared plus y squared plus z squared. So obviously finding rho is just going to be the square root of those numbers. I want us to know that rho, again, just like with the cylindrical, can only be positive. The radius can only be positive, so can rho. Theta, just like before, is still going to be bounded from 0 to 2 pi. And then our phi is bounded from 0 to pi. So back over here for a second. So again, theta can go anywhere around the z-axis for this. Again, the distance that from z to our rho is going to be what phi is. But remember that we can only go all the way to this side right here. And so this is why it's from 0 to pi only. So phi can only go from 0 to pi. So let's go ahead and go back over here and start looking at the equations themselves. And we're going to say, let's look at how we have spherical to Cartesian. So thing that we're going to look at really quickly, notice in here is that we have phi, then we have our theta, and then we have our rho. Right, so these are our three coordinates, and this is what it is. And we want to go to Cartesian with this. So the first thing we're going to do here is we're going to figure out what x is. And so x is given by the equation that you see right here. So we're going to be using these three equations to go from spherical to Cartesian, and then we'll use these equations here to go vice versa. So first thing I'm going to do here is I'm going to find what x is. And so x is going to be equal to, in this case here, our rho. So we're going to go ahead and just say that that's going to be 2. And then we're going to take the sine of phi. And so again, phi is our third coordinate here, so the sine of pi over 6. And then we're going to take the cosine of our theta, which is going to be pi over 2. And then after we do this, it's just using the good old unit circle values to figure this out. So we have our 2 here. Sine of pi over 6 is going to be 1/2. Cosine of pi over 2 is actually going to be 0. So in this particular example, the x-coordinate is going to be 0. We're going to go ahead and do the same thing here, guys. We're going to go ahead and do y is equal to. Actually, let me change my color on this a little bit so we can just see a little bit difference with this. Okay, so y is going to be equal to, again, our rho, which is going to be 2. Then we're going to take the sine of phi, which is going to be pi over 6. And then, and it's the same thing for that, right? They both have the same equation for that, sine of phi. And then we're going to take the sine of theta, which is pi over 2. And we're going to start simplifying this down a little bit. So 2, this hasn't changed. The sine of pi over 6 is still going to be 1/2. The sine of pi over 2 is going to be 1. So we're going to simplify this down here, and we're going to get the coordinate of 1. So there we go with that. And finally, we're going to then find z. So we're going to use this equation right here. So z is going to be equal to our rho, which again is still 2. And then we're going to take the cosine of phi, and the cosine of phi again would be pi over 6. And so we're going to take z is equal to 2 times cosine of pi over 6. Cosine of pi over 6 is the square root of 3 over 2. And so when we simplify this down, we're going to get the square root of 3. And our final answer for this problem is simply going to be 0, 1, the square root of 3. Okay? So what I'd like for you guys to do here now is take exactly what we did here. If you want to pause the video, and then take the coordinate 4, 3 pi over 4, and then 2 pi over 3, and see if you guys can find the Cartesian coordinates for this spherical one. So pause it, and we'll be right back. Alright guys, so hopefully you were able to do this pretty well, and so here is all the work for what we did with these problems. I apologize for my handwriting. So x ends up being the negative square root of 6, y ends up being the square root of 6, and z ends up being -2. One thing I just want to say here is that I know I keep saying phi for this. I know some people say this is phi. I did look it up, and I think both pronunciations are correct here. So some of you guys may say this is phi. I say phi, but they're hopefully interchangeable, and I'm not saying the same thing incorrectly. So anyways, all right, so we're going to do one more example here, and this one is now we're going to give them the Cartesian coordinates, and we want to go and do them in spherical. So first thing we're going to do is we're going to find out what rho is. So remember that rho is just going to be equal to the square root of all of these things, quantity squared. So instead of writing out -2 squared and then all this squared here, we're just going to just write down what this is. So -2 quantity squared is going to be 4. And again, by the way, since we're all squaring them and we're adding them up, that's why it's always going to be positive. So 2 square roots of 3 quantity squared is going to be 4 times 3, right, which is going to be 12. And then the same thing here, I can go ahead and do the square of 4 square roots of 3 would be 16 times 3, which gives you 48. And typically they give you guys numbers or problems here where even though this looks kind of weird, that the numbers should end up being pretty nice for us. So we're going to get that rho is going to be the square root of 64, which simply becomes the nice number of 8, right? So that's our idea for that particular example. And then we're going to use the most basic one we love. We love the tangent of theta. Tangent of theta is just going to end up being the y-coordinate, which is -2 square roots of 3, all over the x-coordinate. And so we get that when we simplify this down, the tangent of theta is going to be equal to the square root of 3. And so we know that in this particular example. Now, you have to be kind of careful with this problem. So right here, the tangent is actually going to be, you'd think it would be pi over 3, right? So that would be the suggested. But we have to really quickly take into account the fact that both the x and the y coordinates are negative. So since they're both negative, we have to look into the fact that they are in quadrant number 3. We must edit this and actually go and do 4 pi over 3 as our solution to this problem. So just be careful about that right here. So tangent of theta is equal to the square root of 3 positive in quadrants 1 and 3. So we have to use 4 pi over 3 for our answer. And then finally, we have the equation for z is equal to our rho times the cosine of phi. And so we can rewrite this as z over p is equal to, rho, this cosine of phi. And so we can now say that z we have is 4 square roots of 3. We found that rho was 8. And so we now can do the cosine of phi this way. I'm going to keep going back and forth with the pronunciations for this just because I can. And so I get that the simplification for this is going to be square root of 3 over 2. We get that phi here is going to be the inverse cosine of square root of 3 over 2, which we would get as pi over 6. And so this is our final answer for this particular problem. So we have rho ends up being 8. We have theta as 4 pi over 3. And then we have phi as pi over 6. And so you guys have it. We're now talked about conversions of spherical to Cartesian and vice versa. And so in the next video, we're going to start talking about the equations themselves. So hopefully this was helpful, and I'll see you guys in the next video.